Hello everyone, welcome to SNS College of Technology, Department of Food Technology, and I am Vaigopala Vishnu. So today we are in Introduction to Baking and Confectionery Technology, covering the topic of milk, milk powder, emulsifiers, leaveners, antioxidants and improvers. So this video will give you a clear understanding of these important ingredients and how they work together to create perfect bakery products. Let us begin. First, let us see what we will cover today. We will discuss an overview of leaveners, biological, chemical and mechanical. Then we will look at antioxidants, both natural and synthetic, and various improvers such as enzyme, emulsifiers and antioxidants. We will also understand their theoretical role in gas production, oxidative stability and Dow rheology. Finally, we will explore design thinking application, curiosity challenge and a quick summary with reference. Before we move forward, let's quickly recall the ingredients we studied in the previous topic, that is egg, water, salt and coloring agents. Now, let's put on our design thinking hat. Bakers and consumers face many real problems. Bakers often say, my bread doesn't rise evenly, or my product goes stale and rancid quickly. They feel frustrated with inconsistent result and short shelf life. Many are also worried about using too many synthetic additives. In their daily work, they keep adjusting formulas through trial and error. This empathy map helps us understand the real user pain points in baking. Based on these insights, we define two clear problems. So first one is, how might we achieve consistent and controlled gas production using leaveners across different temperature and flour qualities without causing over fermentation or collapse. And next problem is that how might we prevent lipid oxidation and extend freshness while still maintaining a natural clean label tapping. So these problems are directly linked to the basic function of leaveners that complement yeast and sugar fermentation and antioxidant that protects fat from turning rancid. Now let us turn these problems into opportunities. So first opportunity is that how might we optimize Dow rheology, that is Dow strength, extensibility and gas retention, using enzymes, emulsifiers and antioxidants for better mechanicability and super crumb quality. And the next opportunity is that how might we integrate leaveners, improvers and antioxidants together for synergistic effects such as better volume combined with longer shelf life. So our point of view statement is that a commercial baker needs reliable rise and freshness because inconsistent leavening and oxidation limit the product quality and market research. So our goals are to develop innovative bakery solutions that deliver enhanced leavening efficiency, excellent oxidative stability and superior dough performance, resulting in better texture, volume and shelf life. We must respect constraints like regulatory requirements, clean label trends, cost, enzyme specificity and sensor impacts. The measurable outcomes we aim for are increased specific volume, reduced peroxide values, improved crumb softness and extended freshness. So all of this must support the role of flour, gluten, yeast activity, sugar and fat. So in this ideation stage, we brainstorm several ideas. For leaveners, we can use hybrid system that combine yeast with chemical leaveners like baking powder for more controlled rise. For antioxidant, we can blend natural sources such as tocopherols, rosemary extract or phenolic rich fruits by production with improvers. For improvers, enzyme cocktails containing amylase and oxidase together with natural emulsifier can greatly enhance the gluten strength and reduce the staling. Some wild ideas includes using upcycled fruit peels as natural antioxidants, improver combination and pH adjusted leaveners for clean label products. The key is to synergize everything with flour structure, yeast fermentation and fat protection. Next comes the prototyping. We can prepare small dough batches to test the chemical leaveners versus the biological leavener along with the different improver blends. So we can run antioxidant trial by adding natural extract like tocopherol to fat-rich dough and measure the peroxide value to check the oxidation. We can also create an improver mock-up by baking small-scale bread with enzyme and antioxidant addition to the access of the final volume and the crumb quality. So, in the testing phase, we use sensory panels to evaluate the texture and volume along with the objective test like specific volume measurement, shelf life storage studies, and peroxide or rancidity assay. Key metrics are rise consistently, reduced antioxidant level, and improved dough handling and crumb softness. So, based on the result, we iterate. For example, reduce the oxidation level in the gluten becomes too strong and tough. We always look back to the empathy stage where real user validation. So, let's quickly summarize what we learned today. So, learners are responsible for gas, leaveners are the responsible one for the gas production and volume. Antioxidant protects against the rancidity and extend the shelf life. Improvers improve the dough rheology, strength, gas retention, and crumb quality. So, when combined intellectually, they deliver a bakery product with a superior volume, soft texture, and longer freshness. So, thank you so much for watching this video. If you found this useful, please like, share, and subscribe to our channel for more baking and confectionery technology lectures.